Hi, hello. Welcome to the MeteorHacks Show. I think this is a very exciting day for us because we are very excited about scaling stuff related to Meteor, actually, scaling and performance. So this time we build a really cool package called Cluster. So I'm trying to show you how we can use that Cluster package and how to actually load balance Meteor application. And I have my friend Tanish with me. Tanish.
Hello guys, I work with Arnold here at MeteorHacks. I'll try and do the demo part and maybe answer some questions.
Okay, right then let's go for the presentation from the beginning, right? So let me share the screen for you guys. Okay, right. Okay, right. Okay, I think I'm at the end of the presentation. Right. Okay, cool. So what we're trying to do today is trying to show you how to show you how we can scale a Meteor application. Right. Then I'll show the story of ourselves and how we actually scale Meteor. First, at the first, when we are developing an application, we just simply use one instance. Like it's a simple instance from DigitalOcean, and then we put it behind the DNS provider from Cloudflare. So then users gonna access our website like this. So this is very simple setup. And then, so after when we are trying to launch our product, so then we need to have more instances, more powerful servers. Then actually it's then we have two servers. Then we also need something for the load balancing. Then we choose HA proxy. Then okay, now we have configured the HA proxy for these two instances, and then we configure the DNS to the HA proxy, and the users can access the our website, and everything works fine. And in the launch day, actually there was a problem happened. So suddenly the HA proxy goes down, and actually we couldn't find out the reason because we are not super good at HA proxy, so we couldn't actually find out the reason. So then, so we thought like, okay, this is something we have to do something more. So then after that day, we have two instances of HA proxy, right? And then we have two instead of HA proxy. Now, like, so what I'm trying to show you guys is this is something very complex setup. So we have a lot of other servers like HA proxy, something like Meteor and DNS and so stuff. So what we're trying to do is we're trying to find out some way to simplify this process. For an example, so these are the issues we have. So this is very complex, and we are not really good at HA proxy stuff. Like so there are a couple of things we have to focus on, and so adding a new Meteor instance is not easy. Like we need to configure HA proxy, and we need to do some other things as well. So we can use some script to automate this part, but it's like it's not simple. So then we thought someday, but if yeah, you can use a Nginx as well, of course. And then, but if we could use only Meteor, so we don't need to worry about using Nginx, HA proxy, or some other load balancing layer. So that's actually what we're trying to do now. So now, so all the traffic, all the users are going to access the Meteor instance, and then Meteor instance will automatically load balance the uh, the uh, actual users to the actual Meteor instance. So this is our server. The actual users come to the one instance, and then these two, all the users will be routed to this instance, this normal instance. So actually, one of the coolest part is, so there is no need to configuration. So you only have to start this new instance and automatically, so all the configuration will be happen. So we do this by using a central MongoDB repository, MongoDB database. So this MongoDB will be used to automatically configuration based on that. So you don't need to worry about configuring anything. So all you have to do is just spawn new instance, add new instances, and then it will automatically scale. Right. And then let's say what if there are a lot of users trying to access our website, and then we can actually use one instance to accept this traffic. So then we'll do something. So earlier we have added two HA servers, but right now we are in this setup. We are currently using only one Meteor instance to accept the traffic. So this is not going to work if we are using some high traffic website. So then we come up with a new solution. So we think, what if every instance, every Meteor instance is a load balancer? So everyone in your Meteor, every instance of a Meteor application can accept user requests, and it can load balance accordingly. That's what we are doing right now. So here only the DNS provider is only configured to the one or two servers, but we can have more other servers as load balancers. So you don't need to put everything as a load balancer, but you can select some servers and you can target them, some of them as load balancer. Then automatically Meteor will take care of the load balancing part for you. So still here, there is no configuration. You have to do much configuration. I'll show you how to do that one right now. Right. The benefit of the system is there is no single point of failure. So that means if one instance goes down, then you can go to the other things automatically, and this package will take care of all the things. Right. Then so we can distribute the DDB traffic between all the instances of our system. So there is no single point, and we can have efficient load balancing system. Everyone in every instance in your cluster is a master, so it's very easy to scale. Right. Then let's see how this works. The first, the website, let's say bulletproofmeteor.com, is asking the initial HTML, and then it will give the initial HTML to the browser client, and then browser client is asking something very called socksjs as info. This is something some kind of configuration stuff asking to connect to the DDB server, and then so with this configuration, then it will connect to the WebSocket or the long polling or other stuff, right? So we are using some kind of internal sockjs API for this one. By doing that, we have extended this capability, and then browsers can automatically connect to these individual instances. So they need to go to a single instance. They need to proxy to a single instance. So I can show you right now. So let's go to the Bulletproof Meteor website. So I can show you. So let me open a browser. Right. Give me a second. Okay. So let's try for the bulletproofmeteor.com, and then you can see I'm on the bulletproofmeteor.com website. Then I'm opening the network tab. Okay, and all right, and then let's right, then I'm reloading it again. So if you look at the these files, there's a special request, HTTP request going called info. In this HTTP request, the response would be something like this. Right, where it is. Okay, I need to get it back. Right, this one. Okay, so now we have some kind of JSON document here, and then there's something called base URL. So that means this document tells us, okay, now for the WebSocket, try to get it from this URL. So that's how we are trying to load balance our cluster. Actually, we are trying to load the app from bulletproofmeteor.com, but actually the WebSocket connection is made from this one.bulletproofmeteor.com. So by doing that, so we can efficiently load balance the our request to all the clusters, or all the instances available in the cluster. So that's what we're trying to do. That's what we do with this our solution. So let's see how this can be done, implemented using Meteor, how it can be used in your application. Right. Let's come back to the presentation, and then it's very simple. In the Meteor configuration, so first you need to add our package. We'll show you how to do that in a second. And then all you have to do is in the Meteor configuration. So you need to add these two environment variables. So one thing is cluster discovery URL with the MongoDB URL, and then you have to do this cluster service equals web. So this is something you have to do always. So this is the only thing you have to do. So you don't need to do this with Meteor. If you see some other ways to deploy your servers, just expose these two environment variables. That's all you have to do. All the cluster will manage all the balancing part. So this is something optional. If you are using balances, if you are transferring one of your servers as a balancer, then you have to expose this balancer URL as well. So this URL is a publicly accessible URL to this instance, right? So this is the setup. This is the only setup you have to do. You don't need to configure IP addresses from anywhere else. So this is the only thing you have to do. It's very simple. So right. So now so benefit of this system is, so there is no need to install some tools like Nginx or HAProxy. I know some of you have very do that Nginx or HAProxy, but so we don't need to worry about these two. And the other thing is there is no configuration. So whenever new instance comes up, so automatically it's available for the cluster. We can scale horizontally as we like. So and the every instance is a load balancer. Every instance can be a load balancer. So we can scale horizontally very effectively. And then so this works with any hosting provider. If you can spawn a new instance, new server, and it can be bind to an IP address and port, and then that's only you need to have. And we can do something like A/B testing with this one, because we have two different applications running behind the one system. And of course, you can extend the load balancing logic using JavaScript. So this is something very nice. So we have built all the sticky sessions and everything related to Meteor. Just you have a very simple API to extend the load balancer, and you can add your own logic and so on. And this is, and finally, this is very good for microservices. And in the end of this presentation, I'll show you how to use this with a microservice. Right, that's it. Right. So now, how do we compare this with HAProxy or Nginx? So yeah, it's tricky. And let's say Nginx and HAProxy, they are battle test and proven. There is no argument with that one. So you have to agree with that one. But we are also using something called Node HTTP proxy. It's a very popular proxy solution in Node community. So these solutions are also very good. At the same time, if you're using Nginx or HAProxy or some other solution, so then you need to have a good configuration for Meteor as well. So otherwise, you might have some issues. So that's you need to think about a little bit. And also, so we do automatic discovery. That means that you don't need to configure for the IP address and servers. This is automatically handled by our solution. And so we have some solution for the HAProxy and Nginx for this kind of stuff, but they are also some kind of not very mature. Right. In the future, we try to add more algorithm for the load balancing. Right now, it's using the round robin algorithm, and then later on, we try to efficiency load balance based on the CPU, RAM, and other stuff. And so that's what we're trying to do. And Tanish, I think now you can. So this is a GitHub repository, you can go there and try to see the documentation. And right now, Tanish will help you guys to do a demonstration of how to actually use cluster and how you can very easily deploy and scale a Meteor application. Tanish?
Thanks, Arnoldo.
Okay, I'll share the screen.
Shall I start?
Okay, sure.
Okay. I'll try to create a local cluster with a few Meteor apps. The one thing you need when you're creating a cluster of Meteor apps is a couple of Meteor apps, because definitely you can't create a cluster with a single Meteor app. And the next thing is you will need the MeteorHacks cluster package. Simply install this package to each and every instance of your Meteor application. And while it's doing that, you must also have a separate MongoDB to store cluster information. It will keep information like when was the instance active last time, and it will be used for service discovery as well later on. And while it's doing that, you must configure your cluster to use each other. Use it by cluster.connect and give your Mongo URL here. The Mongo DB you are going to use for clustering.
Can you increase the font size?
Okay. Enough?
Right, that's kind of
okay. And the next thing is you must register your cluster as a service. And when you are doing this, name your service as web. Arnaud will explain about services later. Let's go with it right now. Do this for both instances. I think the package might be installed. Okay. After that, simply start both Meteor applications.
Can we increase the font?
I have a copy of this application running on port 4000 and another on port 5000. If you check the application, we actually went to localhost port 4000, but what it says is it's actually serving all DDP requests via the application, which is running on port 5000. I'll show what it's doing in the. It's actually just returning the root URL. So the method with a method call. So when it says is localhost 5000, the DDP method is actually processed on the Meteor instance, which is running on port 5000. Although we actually went to port 4000. This is actually managed by a cookie. So this cookie says which instance is written.
Yeah, that's the
thing. Okay, and we can, if we actually remove this cookie, the next time we enter this application, it will try to assign another instance to serve our DDP request. Let's try refreshing it. Okay, this time it gave us the 4000. Let's try it again. Again 4000. It's random. It can happen. Again 4000. Oh man, I want to get 5000. Okay, right, got it. Another interesting thing is this is I took the terminal which was running the 5000 Meteor instance, and if I kill it, the application will automatically move to port 4000. It will happen. Okay, got it. You can see clearly that now it's serving 4000, although it was actually serving 5000. So what is happening is when we add new instances of Meteor application, so if for some reason some of our instances went down, the users who are working with that instance no need to worry, because they'll be automatically assigned to some other live instances. is managed by the MongoDB we were using earlier. This was running a cluster on local system. If you want to do it live, you can use map to configure a couple of servers and do it. We have got a few servers running on DigitalOcean. This server is live, and we have shut down these two. If we check it, it is serving from that server. And if we turn these two on, I'll try it a couple of times to make sure. Okay, again, it should give us the same thing because that's the only server running. If we start these two, should successfully balance it with other stuff. Okay. It might take some time. Anything to?
Yeah, there are some lot of question on this one here in the chat room, and one question is asking about how we can use this with other deployment methods. And then that means you don't need to do with this map. Like you can use this Docker or anything can be bind to IP address and port. So then you can use this.
Actually, we can do both. I can't. With the future map, we are actually working.
Yeah. Actually, in the future, we are trying to implement Docker support for the Meteor app as well. So that means with that we can deploy any Docker image, or we can deploy into any kind of operating system. That's right. That's it. So yeah, you like to know about the A/B testing. Actually, there is no way to, like it's not a proper way of doing A/B testing, but so we can run two instances of our application. So that means two different applications. So then cluster can be used to load balance between them. So now it's doing the round robin algorithm to select the server, but I think at some time you can extend the API with using JavaScript. So then you can add your own algorithm to get the users into that server. Yeah, that can be done. Actually, I'm not familiar with the hardware load balancers. Sorry for that. Right. I think it could work. No, there is no security kind of stuff right now. So actually, we are also working with something called firewall, some MeteorHacks firewall. It is something like a EDP level. It's not a DDoS protection tool. It's EDP level DOS protection tool. So that means you can have some kind of rate limiting system baked into the DDP level. Right. That's it. Danish, I think you can carry the next.
Yeah, I tested it out and it's working. If you try deleting the cookie, it will assign us a new instance. This time we got the same thing, and next time, yeah, this is something. This is different. This is 226. This is 225. We got another instance this time, and if the 225 instance goes down, it should give us something else. Just like when we were doing the local test. Actually, it's the same thing going on.
Right. So that's what we're trying to show with how to scale with the Meteor and using cluster. So that's the idea. So you can easily deploy any Meteor instance to a cloud using Docker or some other tool, and then you can use cluster to manage these services and these instances and load balance between them. So this is the first part of our cluster tool. So there are a lot more things coming up. So then I'll talk about that in the next session. Then we are talking about the microservices. Right, and I'm extremely sorry about this speed of my talk. and I think I need to improve that. So I always trying to say that I need to improve that, but I never do that. So, sorry for that. Okay, so right, I think I'll do a complete blog post on how to do this one and everything from the witness, so you don't need to worry about it. Right. Okay, right, stop presenting. Right, back to me. Right, then what we have to do, we just can start the presentation or we can take some questions. Right, he's asking, there's a question asking how we can set up multiple instances on one droplet. Right, there's a feature on the Meteor Pro to do that one, and so you can go to documentation for that one, but we are not recommending to use a droplet to do that, because droplet is very small and you can spawn more instances in a production environment. But if you're testing, yeah, you can do that one. Right. Okay. Right, then let's take one or two questions from the our list on the right. Let's get the Docker one. And actually, I have created a hackpad with some answers for these questions. I'll share that first to the chat room. Okay, and then I'll take some questions. The first of us is Docker and CoreOS and CentOS and all other things. And he's asking about how to implement Meteor with CoreOS, Docker, CentOS, not Ubuntu. I think this is something related to the Meteor app. And actually, we are working with a new version of Meteor. It can be using the it can use the Docker as a runtime for the deployment, so we can have that one. Right. Okay, and then so if you want to know about CoreOS and other stuff, so there's some links on the hackpad I have shared. Try to go and look for that. And then there's a next thing we want to talk about. I think let's go like queue background jobs. And currently we are using a several method to queue background jobs. And one way it is we are using Heroku. Heroku has a functionality called schedulers. With Heroku schedulers, we can schedule some tasks. So, and then once the service come up, then we are using DDP to connect to our main server and do something. And there's another package called from the Percolor Studio. It's called Synchron, I think, and you can use that as well. And of course, there's a good package from npm module from the Node.js. It's called Q. Like you can use that as well. Right. So let's see more question on the chat room. Yeah, there's another question of Nginx for the static serving. Yes, we can use Nginx for that one. And actually, we are using Cloudflare, so it's also using a flavor of Nginx. Right. And I think now we can go for the next presentation. I think we don't need to waste more time on this. So after the presentation, then we can come back to the questions again. Right. Okay. So let me find the other presentation. So it's about microservices. Right. So desktop. Okay. Right. Okay. Slideshow. So this is about using microservices with Meteor. So microservices is some kind of okay. Sorry, it's auto playing. Okay. Microservices is some kind of hot topic these days. So everyone trying to use microservices term and doing that. So I'll show you what actually microservice is and how you can build a microservices cluster using MeteorHacks cluster. Right. The first, let's look at an application. Let's say our application needs something monolithic. So then it will be something like this. This is our Kadira application. So we have data receiving part inside a single application. We have the alerts, we have the aggregation, we have the web components and the UI and everything in a single application. Actually, this is not the way we are currently doing now. If we build this in a monolithic way, this is the way how we do it. And actually, there are some problems with this one. It's very hard to scale. That means if you need to scale, let's say for the alerts, so then you need to scale the whole application, and then you need to scale the aggregation part. So you can't only scale this aggregation part only. And there's another issue with the code management. So this code will be there with a lot of code, and we could not actually manage them. We can now organize them in a better way, because these are different systems, and we can't use one way of managing architecturing those things. And next thing is access control. So let's say we need to give one service to one set of users, other to someone else. Then we can't do it with a monolithic kind of application, single code with a single code base. So the next approach with microservices. So then we can create tiny services for each of the tasks. That means we can have a web service running for all those interactions. We have running aggregation in another service, like that. So then we can have interaction with each other using some kind of HTTP API, or we can have DDP API or something else. So it doesn't matter how we actually communicate, but so we can have an architecture like this. So this is what we call as microservices. And let's say you might think about something else, but how about microservices and service-oriented architecture? So we had service-oriented architecture from the 80s or 60s, but microservices is something really new. So I can show you right now, because you can see this is the Google trends for the microservices. Actually, it's starting to rising up around, I think, 2014. So now it's rising with a very high rate. So what's the difference? So what's the difference between microservices and the service-oriented architecture? Actually, it's like the big data. So like we had all the things in the past, but actually it's not widely used. And so the service-oriented architecture is not about enterprise applications. So we haven't used for the day-to-day applications. Now the microservices we can use with any application we are writing right now. So there's a reason for that one. So these are the main issues with microservices. So in here there are a lot of services for the web, data receiving, alerts, and aggregation, and so on. Then we need to keep where these services are. Then we need to keep track of what are the new services and like that. So we need to do the bookkeeping part. And then there will be a lot of services. Then we need to find a way to deploy them. So these are the main issues with the microservices. So there are some solutions for this one, but earlier these solutions are only limited for the enterprise and like that. So everyone in the community like us, we can use this architecture in a scale. So then now everything going to change, because we have low cost hosting solutions and we have very cheap hosting, and so hosting is not a problem these days. So we can spawn new servers with each of these services. And technologies like Docker, CoreOS, and other stuff can help us to really deploy services very easily and very effectively. And we have easy to use service discovery solution. That means service discovery solution is something like this. So let's say if you're having a lot of services here, so we don't need to keep track of each of the services. The service discovery solution will tell us where exactly these services are. So we don't need to worry about that. So there was some solution for that one. Earlier we had something called Zookeeper for the Java community. So currently it's also using right now. But the problem with Zookeeper, it's very hard to manage, and the APIs are not very simple. So that's the reason for the very hard to use. But right now we have some tools like etcd and Consul. So with those solutions, they export some HTTP APIs. So we can simply use very easily. So the technology and everything is going to be going very simple and easy to use. That's why this microservices architecture is kind of evolving and rising. And what do you think? We talk about a lot about microservices. Then how microservice and Meteor can relate? And actually, Meteor is perfect for microservices. Actually, the reason is we have DDP. We can connect with each other using DDP, and we have PubSub, we have methods, and everything is there. And all we have to do is we have to glue this together because we have a standard way of connecting to the servers, and this is a core part, right? So with Meteor, everything is there. So all you have to do is just glue things together and try to create a way. So that's what Cluster does. The cluster is a service discovery solution. You can register for the services, yeah, just like this. You can connect to the central MongoDB repository. It's a service discovery backend, and then you can register this service as aggregation, like for an example, and then you can connect to another service like this, cluster discover connection. That's a login connection, login service. Then you can log like this. So that means you don't need to keep track of IP address and port. That you can get the connection, DDP connection, by calling a name. So that's the service discovery part of the cluster. Actually, web, that earlier we have for the load balancing, we use something called web as a service. That means we have some special definition for the web. The web is a UI controller. It's a UI service. And also for the other than the service discovery and the service registration, we do load balancing and failovers. That means it's a complete solution for the Meteor. And I'll do a demo. Right. So this is like we need to do a code demo. I think we do it's enough presentation. Right. Let's minimize this thing. I think okay. Right. A lot of windows. Right. We have so this is a kind of like application trying to search Meteor packages. It's a kind of like atmosphere. So we have two applications, two services actually, web and search and web. So I can show you right now. It's like this. Okay, so we have the search here and the web. I think the font size is small. Don't worry about the folder structure. And all right. So basically, our search app is very simple. So it's trying to register to a cluster like this, and it's registering itself as search. And we have a method, expose a Meteor method like get packages like this. And then we have another service, another Meteor app actually is called the web, and it's very simple as well. It's also registering itself as a web to this discovery. And then we are getting a connection here, search connection for the search one. And actually, so you don't need to worry about the search source or defined source thing. So it's something like you can think about a Meteor method for this web application. Inside that, we directly access the search service like this. You can call this get packages method, and you can get the result. So now all you have to do is, so we can run these two applications in our whatever the port we like, and then you can access the application. I'll show you. So let's go to the search app first. So I'm starting with Meteor port, let's say, right, sorry, yeah, Meteor port, let's say port 8007, right? We'll go to the other one as well, like web service. We'll start that one using, let's say, port like okay, 5008. All right, and you can see the right. This one has already started the search service, so it's registering some to the console. And then let's wait until the web service started. So like everything is fine. Right, let's open a browser and let's try to access this thing. Right, I don't remember the port. I think web is in the port 5008. So let's copy the URL. Let's open the browser and let's paste this one. Right, we don't need this one. Actually, we can get a simple Meteor app like this. Now we can search. This search result is coming from our search service. And we can verify that one by, let's say, we can uncomment this definition, this method call, and you can see we no longer can't search. So we can cluster, yeah, we no longer can't search. That's it. Right. Okay. So there are a lot of things we can do this one. So let's say now, actually now we are trying to trick this thing. Right now we are getting this like this search result through the web application from the client. Actually, it's going to the web service, and web service is calling the search service to get the result. But actually, we can directly call the search service from the client, from the browser, and this is actually we do it. So from the our web service, so you need to say we need to allow public access to the search service. Then currently, all the services in the cluster is only exposed to the server side only. They are not exposed to the public. But we can explicitly ask the cluster to do export the search to the public. Then we can access it from the client side. So let's let's comment these two things. So now our service won't work. So we don't have anything server to do that one. And then this is right. This is some old result you are getting, and I can show you the console, and we will see some errors for sure. Right, you can see when you're typing, we get errors. Right, that means our search is not working. I need to double check. And then from the client side of our web service, I can do something like this. I can create a connection just like I have done on the server side, cluster.discover connection, and then I can call the. So don't worry about this API. This API for the searching UI component, and then you can call the search connection.call just like that. Get packages, and you can send it like that. So now I have enabled this one. So now I should be able to search. Right, all right. I mean, I lost the URL. 2008. Now I can search again. So now the actual searching is happening on the client side to the actual search service. I can show you from my browser network. So you can open it. I can zoom it. Go to the WebSockets. You can see there are two WebSocket connections made to the first one for the, you can see here, it's very hard to see, for the web service, and the other one is for the search service. So all these things are managed through the cluster, and you don't need to worry about getting the connection and everything. So I think this is something very powerful. Okay, so let's try to shut down one of these search service. So let's try to search for Arunodha, so we get the result, and let's try to turn off our search service. And now we are getting errors, so we can't search again. So if we try to search for MeteorHacks, we can't search. And then let's say we start this search service using a different port, like let's say like 9000 and okay, whatever the port. And then let's take starting up, and after it has been loaded, it will start to register itself as a search service, and then we can start searching from the UI again. You can see we get the result for the MeteorHacks, and we can do something like search for Facebook, and we can do anything we like. So this is the coolest part of the cluster package, and I think it's gonna work. It's gonna change how we code, how we create applications with Meteor. Right. Right. And then let's go back to the presentation. I think I have more things to share. Right. I think this one. Right. This one. So let's start the presentation. Okay. This is the future of Meteor. I want to show you that after 2 or maybe 1 year from now. So we are trying to write services. We don't go into, we are not trying to write packages anymore. We're trying to write services, and others can use those services. And then all of these services can be deployed with Galaxy or some other similar tools like Docker or something similar. And everything will be talking to each other using DDP. So they could get some help from the packages like cluster, or there'll be some other solutions. And the best thing is, in the future, we will have third-party APIs like MailChimp, Logly for the search, Algolia, and all the other things. Third-party APIs will provide some kind of DDP API. So that's the future I think we can think about. I think this is not going to happen like this. Then we need to work on that. We need to create tools, and like then only we can see a future like this. And actually at Kadira, we are always trying to use microservice from the beginning, but not with Meteor. Right now, we are moving all our services into cluster, cluster package, using cluster package, and we have moved our web service and a couple of some internal services. And after I think for the next month or after that, we are trying to move everything into cluster. And also, we might also write a DDP server from Golang. I think that's maybe the first DDP server implementation for Meteor. All right, that's the thing. And so for the Bulletproof Meteor readers, if you're following Bulletproof Meteor, I have added a couple of chapters, couple of lessons on microservices and how to deploy highly available Meteor cluster and so on. If you can check this one as well. I have more lessons on the cores and Docker as well, including load testing. So these lessons will be available within this week for sure. Right, that's it for the microservices. Right, and then I can ask some questions. Okay. Right, but okay. So there are some solutions. Let's say questions. What happens when a microservice isn't available? Let's say health check every n second. Yeah, there are not health checks from the outside. So then we need to come up with some kind of API to spawn a new things. I think so we can have some service to do that one. Maybe in the future, maybe Galaxy. Actually, the Galaxy is some kind of it's a deployment solution from MDG. That means Meteor Development Group. If you guys don't know about Galaxy, so it will be a very easy way to deploy our application, our Meteor application. Yeah, so Galaxy is the way how MDG is trying to make money from Meteor. I think that's something good. Right. How can we do about authentication from the client? I think from the server side, I think we don't need to worry much about authentication between microservices. Of course, we can use some kind of authentication on the server side because it's simple. But from the client side, so there is no like easy way to do that. Right now, we can extend the login token system that currently we are using for the web service, and we can extend that for the other services as well. Actually, I have done some proof of concept on the Bulletproof Meteor lesson. I will soon create some kind of packages to make things easier available for everyone. We can do the authentication for each and every service as well, and we can do that one. The monitoring, I think, we can build some kind of monitoring solution for this cluster using Kadira as well, of course, for sure. Right. All right. You say something about microservices in Kadira, right? Okay. So we have a couple of services in Kadira, like for the accepting data, and then after we accept data, then we send it back to something called our data layer. It will store the data, and then we have some other services to aggregate, and there are some services aggregating time to time, and there are some alert solutions, and there are some solutions to send emails. So there are a lot of microservices. Actually, we haven't used Meteor a lot for these microservices, Yeah, I think now we are trying to use everything for the Meteor, everything with Meteor. Yes. He's asking how to do authentication. So I think I can do some kind of demo. So this will be something not real, but I can show you this is how we're gonna do it. So let's say for the search application, the let's search service. So we can do something like this dot user ID. If this is not user ID, so we can throw some error. I think you got the error. You got the thing. We can throw some error, and then we can use some. There are some ways to add the user ID for this layer, and then we might can connect. Okay, we might can connect something like this. So I already done that one. We are getting a connection to the web service from the search service, and then we can do some kind of authentication in here, and we can do some kind of authentication. I'll work on a package, and I'll work on a way to simplify this process for sure. But right now we have a documentation on we have a trick way of doing thing on the Meteor for sure. For the within this week, I can work on a package. Right. So that's the benefit of using DDP over the traditional REST calls. I think that's a good question. For the DDP, we can use the actually it's a socket connection. I think we can get good ELSD with that one. But we also can use the PubSub as well. So that's something good. Yeah, I think it's a kind of debate to use whether use to REST or DDP. But I think yeah, something like the DDP will be better because we have a very easy way to do that one. There are bidirectional and persistent. Yeah, there are a couple of things. Yeah, okay. Yeah, I think there are good answers for the in the chat box, right? Right. Okay. Let's see. We have more questions on this, and there are some questions on the indexing. I think yeah, I think it's not directly related to here. I think indexing is something very important. You need to do indexing on the early days. Then after, if you lose indexing on, then so it's very hard to do at the end. And I think I have done some. I have had some links to this hackpad. I think we can use that. So there are a couple of questions on how we can use scale using Amazon Elastic Beanstalk, using Amazon AWS, and there are some other solutions like code deploy. Yeah, I think I'm not exactly sure how to do that one, but if they can spawn a ET instance and they can bind to IP address and port, I think it could be able to deploy and scale using our solution. Because earlier, so in that one, they need to put some kind of HA proxy or Nginx with that one. But right now, we don't need to worry about that one. We can simply need a solution using our cluster service. I think for the Amazon Elastic Beanstalk, they do support something. I think they do support Node.js. I think then you can use our Meteorize package to convert the Meteor app into Node.js application and try to use our cluster package for the load balancing. Right? Yeah, it's a good idea to serve static files using Nginx. But if you are using a lot of files, I think it's a good idea to use some kind of S3 or CDN for that one. Right? Okay. Any thoughts on DDoS prevention on the TDP level? So I can show you. Yeah, actually we haven't completed working on this solution yet. So it's called MeteorHacks Firewall. So actually it's a Meteor package. So what we're trying to do is we try to rate limit on the DDP level. So then you can actually do some protection for the DDoS attacks. So I can share that as well. It's not a complete solution. Right. So there's another question on the chat. What about using a simple event emitter between microservices via DDP rather than using full PubSub? I think that's a kind of, yeah, we can think about that as well. And there are some solutions on the node as well using this distributed event emitter pattern. But I haven't seen they're catching up at the early 2012, 13 line. But I haven't checked recently. I think that's another good way to think like that one, like kind of a distributed event emitter. That's a good idea. Right, we answer this one. And observe it's the same thing as AWS Beanstalk and everything. Right, right. I think I will show you the how to set up a multi-instance setup. I'll create a blog post and I'll show how to do that one. Right. Okay. Right. Right. That's it on the question side. And if you have any question, I can wait a couple of minutes if there's something. Right. All right. Okay, there's another thing we are trying to do. So if everyone is looking for, we can create some kind of discovery backend for the cluster. Then you don't need to use MongoDB for that one. And if everyone is interested to do that one, we can run a pre-service for the to get the high availability kind of discovery backend for the cluster. That can be done if everyone is interested in using this kind of architecture. Right. There's another question on the cluster require upload. No, it doesn't require upload. Actually, it uses a MongoDB to periodically get the state of the MongoDB. So actually, it's very simple at Mongo request to every 10 or 15 seconds, I think. So you don't need upload for that one for sure. Yes, we have used Tracker on the server. Actually, it's not reactive programming. This kind of hack we have used. So I don't know for some solution, some reason. So we need to get the state of the DDP connection on the server. So right now there is no way to get the state of the DDP server, the state change of the DDP server, DDP connection on the server using some kind of hooks or callbacks. So then we run the DDP connection inside the tracker, and then we can get the status using tracker, just like we do in the client side. Right. I have seen some people using tracker on the server side, but I generally it's not a good idea to use tracker on the server side. The reason is so when using tracker, so it's actually rerun all the content. So if you have done some server side query or something, then it's going to rerun again, and then that's some kind of problem. So we should avoid using a tracker on the server as possible as we can, but it's not a rule. Right. I think Adrian is asking about Erlang OTP ecosystem. Any thought of integrating Erlang and DDP to? Yeah, I think yeah, Erlang would be some good solution. I have only heard about Erlang, but I haven't used Erlang actually, and I think it could be a good thing. But the problem with so how about the developer community? I think Erlang community is very small compared with other languages. Actually, we are trying to write the GDP server in Go, and then actually we are trying to move our services into Go recently for the aggregation part. And I think we can have for the Go, and someone can write. I think Adrian, you can write something for the Scala, and like this. And for the since you are working with the Java, so that's it. And there's a question on the load testing as well. So I can share some. I think I have shared some links on the Hackpad. Yeah. Actually, we are working on something called Meteor down as well. It is a kind of load testing solution. So we can do stress testing and load testing using that one. It's using the DDP connections, so it's very lightweight to use, and we can scale this using Heroku for free, and we can have a very high 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 level load testing solution. Right. Closure maybe, yes. Right, okay. I think that's it for the video and this show. I think in the next episode, I think we can do flow, or we can do the firewall thing. Just try to see. Right, okay. Thank you guys very much for the coming here and helping us to work on the question and other stuff. I'll be in the chat for I think around another 30 minutes or maybe or later. So we can still ask questions and discuss. Okay, thank you very much. Anish?
Okay.
You guys
Thanks,
know-
guys.
Okay. All right, okay. Bye.
Bye bye.